Hello students, in this video I will continue compound angles. Okay. In this video I prove the theorem cos of A plus B is equal to cos A cos B minus sin A sin B. In order to prove this theorem, I will consider a unit circle. This is a unit circle, okay, x-axis and y-axis, and this is the origin. Origin is the center. Okay, now let P1 be a point on the circumference of a circle such that angle XOP1 is angle A. Angle XOP1 is angle A. Then what are the coordinates of the point P1 on the circumference of a circle? You know, for any circle, if the point of the circle makes an angle A, then the coordinates of this point on the circle are r cos A, r sin A, isn't it? But here I have considered a unit circle, means r is equal to 1. Therefore, the coordinates of P1 are cos A, sin A. Okay, this is angle A. Now, in order to prove that I want A plus B, I will choose an angle from this point P1 to this. It is an angle B. Okay, this point. Okay, and then I will join the center with the point at which this angle B meets. Now, this is angle A and this is angle B, means this total angle will be A plus B. If this total angle is A plus B, then the coordinates of this point P2, coordinates of angle XOP2 is equal to angle XOP2 is equal to angle A plus B. Therefore, the coordinates of P2 are cos of A plus B, cos of A plus B, sin of A plus B, isn't it? Now, if this H is angle B, okay, I will consider the same measurement along the x-axis in an clockwise direction. It is as same as B, but in clockwise means this measurement will be minus B. Okay, then the line which meets the circumference of a circle at angle minus B is P3. Since this angle XOP3 is equal to angle minus B, we have the coordinates of P3 as cos of minus B, sin of minus B. Okay, that's what I have written here. Since cos of minus B is cos B, cos of negative angle is positive, then sin of minus B is minus sin B. Therefore, the coordinates of P3 are cos of minus B, sin of minus B. Then, from the figure, this length, it is cos A, sin A, and this is cos B, minus sin B, means this is angle B, means P, when we join P1, P3, it is as same as joining P2, P4. Since this point P4 is on the x-axis and this is a circle of unit radius, the coordinates of P4 are 1, 0. Therefore, we have P1, P3 is equal to P2, P4. Or by squaring on both sides, I can have P1, P3 square is equal to P2, P4 square. By the distance formula, I can find out what are P1, P3 and what are P2, P4. What is P1, P3? Since the coordinates of P1 are cos A, sin A, and P3 has cos B, minus sin B, I have to write x2 minus x1 whole square, cos B minus cos A the whole square, plus minus sin B, y2 minus y1 minus sin A the whole square. This is equal to, we will expand it by the formula A minus B whole square, cos square B plus cos square A minus 2 cos B into cos A or cos A into cos B. Then plus, in this bracket I have minus sin B, minus sin A, means minus sin B the whole square. If I make, it is sin square B plus sin square A plus 2 sin A into sin B. Okay. Now this is equal to, I have cos square B plus cos square A minus 2 cos A cos B plus sin square B plus sin square A plus 2 sin A into sin B. So what we have? Cos square B plus sin square B is here. Cos square B plus sin square B, together I can call it as 1, plus cos square A, and one more term is there here. It is sin square A. So cos square A plus sin square A is 1. Then I have minus 2 cos A into cos B plus 2 sin A into sin B. I will call this as equation 1. Similarly, I will find what is P2, P4 square. What are the coordinates of P2? P2 has the coordinates cos of A plus B, sin of A plus B. P4 has 1, 0. Means x2 minus x1 means 1 minus cos of A plus B, x2 minus x1 the whole square, plus y2 minus y1, 0, y2. Then y1 is sin of A plus B. So 0 minus sin of A plus B the whole square. Let me expand it by the formula A minus B whole square. 1 plus cos square of A minus B minus 2 into cos of A plus B. Then plus, anyhow there is 0 square, 0 minus sin of A plus B means minus sin of A plus B, minus the square means it becomes plus. So I am left with only sin square of A plus B. What we have? Cos square of A plus B, here plus sin square of A plus B. Suppose I call A plus B as some angle say theta, it is of the form cos square theta plus sin square theta. I can replace it by 1 minus 2 into cos of A plus B. Here 2 minus 2 cos of A plus B. Call this as equation 2. You know from the theorem P1 P3 square is equal to P2 P4 square. What is our P1 P3? 2 plus, here it is, 2 P1 P3. It is 2 plus cos of cos A cos B plus 2 sin A sin B. 2 minus 2 cos of A plus B P1 P3 is 2 minus 2 cos A cos B plus 2 sin A sin B is equal to, what is P2 P4? P2 P4 square is 2 minus 2 into cos of A plus B. 2 minus 2 into cos of A plus B. Now there is 2 here, here also 2. It gets cancelled. Here I can take minus 2 common. I am left with cos A cos B minus sin A into sin B. There is plus sign here, but when I take minus sign outside, I am left with negative sign inside the bracket. Then minus 2 into cos of A plus B. Then minus 2 and here also minus 2, that gets cancelled. Thus we have cos of A plus B is equal to cos A into cos B minus sin A into sin B. Thus we have proved two theorems. Cos of A plus B is equal to cos A cos B minus sin A sin B, and one more in the last video you have seen cos of A minus B cos A cos B plus sin A into sin B. With this we can prove two more theorems, that is sin of A plus B. Sin of A plus B is equal to sin A into cos B plus cos A into sin B. Similarly, sin operating on A minus B will be just differing by negative sign. Sin A cos B minus cos A into sin B. Thus, sin of A plus B is sin A cos B plus cos A sin B. Sin of A minus B is sin A cos B minus cos A sin B. Cos of A plus B is cos A cos B minus sin A sin B. Cos of A minus B is cos A cos B plus sin A sin B. Similarly, I can prove the theorem for tan of A plus B. You know, tan is the ratio for sin to cos. Sin of A plus B upon cos of A plus B. When we substitute this formula and simplify, we get the formula for tan of A plus B as tan A plus tan B divided by 1 minus tan A into tan B. 1 minus tan A into tan B. Okay, practice this formula and be thorough with the theorem. We shall meet in the next video with the examples based on compound angles. I hope you have understood the theorem. Theorem is very important for your examination purpose, so you practice the theorem.